Okay, how's it going, guys? My name's Zach Allen. I'm the founder and CEO of Slate Robotics. Today we're going to do a little tutorial just to show you guys how to get started with simulating the TR1 in Gazebo. The TR1 is a two-armed mobile manipulator robot that we've built. We're excited about it because it's by far the most affordable robot of its kind, and it's allowing people to have access to these kinds of robots that wouldn't traditionally have access to them, like normal people. Okay, so let's talk about this a little bit. So by using ROS, we you are able to kind of swap out layers of uh, programs that are running on the robot. ROS is just a way to kind of organize different nodes throughout your robot that are all performing different tasks, and it just provides a basic protocol for how to communicate between the nodes. So what you're able to do there is if you have a simulation software, you can basically replace those lower level controllers that actually controlled the hardware, and you're able to pull that out and instead place it with the simulation. What I'm saying is that if you write a program at a high level and you run that program on your robot, it's also going to run on the simulation software, and vice versa. So you can program something on your computer using the simulation, and then you could port that over very easily to run on the robot itself. This is very useful because I've done this. You have some ideas for how to program for something you want to program. You can do all of that on Gazebo, and then later go on and run it on the robot itself, and then do some fine tuning to make sure everything runs optimally. So it's very cool. One of the major advantages of that is not only just saves you time, but it also saves you money because, well, if you're programming something that's brand new, just a brand new idea, it's really buggy, you may not have built in all the safety mechanisms or for whatever you're building, right? The robot could crash into stuff, you could knock stuff over off of a table and things like that. These are problems that you don't have to worry about at all with Gazebo. So let's go ahead and jump right into it. Um, so I've written a blog post about this, slaterobots.com. You can see that there, what I have pulled up here. So getting started simulating with Gazebo. I am going to, oddly enough, assume that you already have Gazebo installed on your machine. There's a couple different ways to do it, but if you've installed the desktop full version of ROS, then you will already have it on your computer. So I would recommend that you do that, uh, which the installation instructions can be found here. So pretty straightforward stuff. There are a few different dependencies that we'll need in order to get this working. First of all, we're going to need to install ROS control and ROS controllers if you have not done so already. I've already done this, so I'll go ahead and just run through this. I won't have to actually download anything. Um, it's going to tell me that it's already installed. Then we're going to download and install some uh, basically ROS control plugins for Gazebo that make the ROS controllers and Gazebo play nicely together. And for this specific tutorial, we're going to use Move It. So if you don't have that installed already, you will need to do so. Um, you can see the names of these here. Again, go to our website. There'll be a link in the description for how to find this blog post. So you can just copy and paste everything over there. Okay, and then you'll need to source finally your kinetic environment, and in order to have access to all of those new ROS packages that you've installed. Okay, so those are some of the basic dependencies. Now we get into the TR1 specific stuff. Um, Wherever your ROS workstation or workspace is at, you'll need to go into it and then go into the source folder of that workspace. I think in general, ROS underscore WS is usually what people use. I've seen catkin underscore ws, but wherever your ROS workstation is at, you'll need to um, cd into that. And then once you're into the source folder, source directory, you'll clone TR1 hardware interface, TR1 tools, TR1 Gazebo, and TR1 CPP. All of these are found on our GitHub page at github.com/Slate Robotics. And again, all of these links are found here. You'll need to install, and look, I'll show what I have here. I have all of those packages and even a few more um, in my ROS workspace. So once you've done that, we will go ahead and go back to the root folder of your ROS workspace, and we'll catkin make just to install everything, which I've gone ahead and done here. And then finally, we are going to source our ROS workspace environment so we can have access to those as well. Okay, so that's actually everything you need in order to get started with all of this. Lastly, we can actually get to controlling some stuff with Gazebo. So I have on the TR1 underscore Gazebo package just a basic TR1 underscore empty.launch file, which is just going to open up just a empty Gazebo environment where there's just going to be nothing but a TR1 placed right at the center of the environment of the world. So we'll go ahead and run that. Now keep in mind, this is still in early stages of development. There are still several things that haven't been implemented yet and haven't been fully tested. It is an open source. All of our software that we run on the TR1 and that we use for ROS is all open source. So if you need to modify anything or do whatever you need in order to do what you're wanting to do, be my guest. Okay, so we've got this. Again, we've got a few errors at this point, just regarding the wheels and the base, and also the linear actuator down here, which we haven't implemented yet. So we'll open a second terminal window now that we have Gazebo open. And just to actually double check that we've got everything running properly, we can do a ROS topic list. And we'll see all of these TR1 controller ROS topics where we can publish commands to each of these. If you don't see this, something has gone wrong. Okay, so now let's ROS launch. Can't talk. So we're going to do TR1 tools, and I've wrote a little go-to position. TR1 tools, a go-to position node. So basically this is using MoveIt to just take commands from the TR1 go-to position ROS topic, and it's just waiting for commands for that, and it's just accepting a geometric point with an XYZ coordinate. And what it's going to do is it's going to take the end effector of the right arm, which is currently in the middle of the robot here, and it's going to move it to that point. So next, we'll just need to open up once we can see this is, you can now start planning. This is loaded properly. We're going to open another window, and we're going to publish to that ROS topic our geometric point. And we've just got OX, or 0.5, 0.6, 0.5 as our coordinate for that. These are all in meters, by the way. And the origin position for the TR1, which you can actually see here, well, actually that's for the world itself, but the origin point's somewhere in the middle of the base, and it's going to be perpendicular to the base here. Okay, so now we'll go over to this tab, and we can see that we've accepted the command, um, and it's planning and currently moving to that position. Because this is all quite a bit of requiring quite a bit of processing power, a real-time factor for Gazebo is 0.2, hovering about 2.25. So that means that the speed that you're seeing right here is actually a quarter speed. So if you have a machine that's faster than mine, I'm actually running this all right off of the TR1 itself. So if you have a desktop or some other workstation that's going to be faster than the computer off of the TR1, you'll see better performance with that. Okay. So anyway, slowly but surely it's going to move to that position. In order to switch from the simulation to the actual hardware, all we need to do is set the simulation argument to false. And I can show you the actual launch file that's associated with this package. And we can see our simulation argument. And we can see here, it's just including the TR1 interface, TR1 position trajectory controllers. And it's saying include that if the simulation argument is set to false. So by setting this to false over here, we are thereby including this TR1 hardware interface. In other words, we're not loading Gazebo, but instead we are loading our hardware controllers, which I will run that here. And we can see the gripper has moved to the 0 position, or the wrist roll joint has moved to the 0 position. And there we go, we are ready to take commands. So we can send that same 0.5, 0.6, 0.5 command to that same ROS topic. So the exact same command, and now we're seeing the TR1 move to that position. As you can see, it's a lot faster. The real robot's a lot faster than the simulation version. So let's move this over to here. And we'll move it in the X direction to the that way. We'll move it from 0.5 to 0.2, and it's going to go 300 millimeters that way. The way I've got this program set up in particular, I don't have any control over how it actually plans the positions. But you can see there we go. That's a great demo. So you'll So this is all really basic stuff, right? We haven't gotten into how to do anything crazy, like how to pick up cups or how to, identify objects and move things from one place to another. But this has shown you that you can program something for Gazebo, and then you can easily switch it over just by changing a few basic arguments, and you can run it on the actual robot. We've got a long way to go in order to have the support to be perfect for each of these packages. The support for Gazebo to be perfect. But you should already be able to get in there and start building some pretty cool stuff. And we hope within the next few weeks, over the next couple months, that we'll have some pretty robust support for Gazebo. So if you have any questions at all, please let me know. Check out our blog post at slaterobots.com, and also check out the TR1 if you're not familiar with that already. We are looking forward to seeing what you guys can build, and we'll catch you all later.